All right. In our last video, we talked about graphing quadratics using our calculator. All right. Today we're going to talk about key features of a graph. Okay, and to change a quadratic equation from standard form into a quadratic function. Okay, so we can easier identify some things. Now let's review some things about our graphing a quadratic. First of all, remember our quadratics have a parabolic shape. All right, so this is a parabola. Okay, some key features. All right, we talked about our x-intercepts here, where our graph crosses our y-axis, our y-intercept, where our graph crosses our y-axis, and our vertex, which can be our lowest possible point of our graph or our highest, depending on the shape of our graph. Okay. Remember, our line of symmetry cuts through the middle of the graph, and this kind of acts as a mirror. Right? We mirror points over the line of symmetry. This is my y-intercept. I went over one, up one to get here. I go over one, up one to get to the point on my right, and I go over two, up one, two, three, up the same amount to get to this point as I do to get to that point. Okay. There are different forms we talked about. The standard form of our quadratic equation, which is ax squared plus bx plus c. There is a standard form of a parabola as a conic section, which we'll talk about later on, where I can talk about the focus and the directrix to help me find this 4p value. But that we'll discuss that later on in the semester. We're going to focus on standard form of a quadratic function. This is sometimes also referred to as vertex form because it is easy to identify our vertex just by looking at this equation. Some key components again that we are going to talk about today is our vertex or line of symmetry, finding our x and y intercepts. But we'll circle back to that in a minute. What does it mean to be a quadratic? Well, a quadratic is any function is the degree of 2. All right, or degree of 2. The shape of a quadratic, which we talked about before, and I've already talked about today, is a parabola. Remember from our parent functions, a parabola looks like that. Okay, it's our U shape that goes through the origin 0, 0. Why might it be useful to have a quadratic written in this form? Well, first of all, I know that let's say if my function, my graph was down here, all right, then my new vertex would be over and down. All right, well, why is it easy? Because it's easy to see using my a value whether or not this stretches or shrinks. Thinking about when we did transformations first semester, the a value determines the stretch or shrink of a graph. Okay, how it moves. Okay, my vertex, how my function shifts. Well, my vertex is going to be found by h comma k, which we'll talk to in a little bit in our line of symmetry. Line of symmetry is always this vertical line here that goes through our function. Okay, right here, it's our vertical line that cuts through the vertex, so it's going to be in the form of, then say vertical line, x equals h, or x value of our vertex. All right. I went through that a little bit quickly because it's mostly a review. It's mostly review stuff we've been talking about for a while. Okay, to get the quadratic in the standard form, our option, the only option, I know it says option 1, the option that we're going to do, it's just like completing the square. There are other options out there. There were options discussed in previous years that we are not going to cover this year. Okay, so this year we're only going to focus on completing the square. Okay, well, just like in completing the square, the first thing I need to do is divide everything by my leading coefficient, isolate both x terms, add b over 2 squared to both sides, write as a perfect square. And this one is going to be different now. We're going to isolate our f of x term. Isolate, that should be f of x, not just x. F of x. We want to isolate our f of x. And you'll understand what I mean when we try an example. So first thing I need to do is divide everything by 2. All right, so I'm going to divide f of x by 2, but I'm just going to leave it as f of x over 2 equals x squared plus 2x minus 7 over 2. isolate my x terms, f of x over 2 plus 7 over 2, leave some space, equals x squared plus 2x plus blank plus blank. Next thing, divide b by 2 and square it. 2 over 2 squared. 2 divided 2 is 1. 1 squared is just 1. 1. Alright. Continue on to write as a perfect square trinomial. Well, I know that this on the right should be x. This is a positive 1, so plus 1. Excuse me, it's a positive 2. 2 divided by 2 is going to be positive 1. Alright. This, some fraction work. 1 is just like 2 over 2. So really this is 9 over 2 plus f of x over 2. This by itself. So now, in the past, what would we do? We would square root both sides and solve from here. Well, now I want to isolate my f of x, okay, and solve. Isolate for f of x and solve for f of x. So we're going to solve by isolating, or isolate by solving. No. Solve by isolating. So x plus 1 squared minus 9 over 2. So now my f of x has this 2 on the bottom, so I'm going to multiply both sides by 2 and multiply everything over here by 2. Alright, so because I just want f of x, not f of x over 2. So this becomes f of x equals, if I multiply here, I'm just going to leave it on the outside, 2 times x plus 1 squared, and then 9 over 2 times 2 minus 9. Okay, so this would be our quadratic form, or also known as vertex form. All right, the vertex here, okay, remember, I have, this is our form that we're looking at right now. It's x minus h squared plus k. Well, since it's x minus h and I have this positive 1, I do the opposite, so my vertex is really negative 1, and then the negative 9 on the outside. Line of symmetry, x equals negative 1. All right. To find my y-intercept, y-intercept is when x equals 0. Now, I could do this two ways. I could substitute 0 in for x here and solve it out, or I could substitute 0 in for x into my original, into the standard form equation, and figure out what y equals. This standard form would be a lot easier because I have 2 x terms and 1 left over. So I'm going to substitute it in here. All right. So if I plug 0 in for x, that's 2 times 0 squared plus 4 times 0 minus 7. So that's going to give me negative 7 because this will cancel and this will cancel. So my y-intercept is 0, negative 7. Okay. To find my x-intercept, I need to set y equal to 0 and solve for x. Well, another way of writing f of x is y. So I could go back to my standard form equation and use the quadratic formula, but I already did all this work to put this in, or already did all this completing the square work, so I might as well use it and just do some solving for myself. Let's complete the square. Add 9 equals 2. Let's solve by using the square root. Excuse me, we already completed the square. Divide by 2, 9 over 2 equals x plus 1. Oh my goodness, squared. Square root both sides. So I get 3 over root 2. That's going to be plus or minus equals x plus 1. Subtract the 1, so x equals negative 1 plus or minus 3. And now I know I need to rationalize this, so I'm going to do that now. Times root 2 times root 2. So this would be 3 root 2 over 2. Alright. Yes. So those are our x-intercepts. And I can write those as ordered pairs as well. Write those as two separate ordered pairs. But I'm not going to do that. We're just going to save ourselves some time. Alright. I want you to do this one yourself. I want you to write in standard form and then find the vertex and find the line of symmetry as well. Alright. Okay, here we go. Here's my work. I divided everything by -1. Took half of 4 and squared it to get 4. This became 5. This became x plus 2 squared. Moved the 5 over. Isolated f of x and solved, so I multiplied everything by -1. Every single term. At -1's canceled here. -1 there. Plus 5. Vertex is -2. 5. X equals -2 for the line of symmetry. Alright, so now we're given the vertex. We want to find the quadratic function. So remember, our quadratic function looks like this. F of x equals a times x minus h squared plus k. Alright, where this is, our vertex is h and k. This is x and y. Remember, f of x is another way of writing y. So all I'm going to do is throw what I know. Substitute in what I know to help me find my a value. Similar to how we would solve for b when find the y-intercept. Same type of idea. Now solve for a. So I want you to pause now and I'm going to solve for a. Again, I substituted everything I knew. I knew that x was 2, y was 3, h was 6, k was -1, and I'm solving for my a value here to get 1/4. And I write it as a quadratic function just like this. Okay? Why don't you try number 6 now? Go ahead and try number 6, and I'll put up my work in a minute. All right, go ahead and check your work on that one as well. Again, I substitute -7 in for f of x, or my y, -5 in for x, -3, which makes this +3 in for h, -4 in for k, and solve for a to get -3/4, and wrote it as a quadratic function. This next one, extra problem if you want some practice to put in the standard form. You can pause the video and check your work. I'll show you my work, or show you some work for this one. All right. After you check your work, that is it for 7.7. Here you go. This one's a little bit messy because of the fraction. All right. This is a 2/3. Okay. 2/3 here, so I divide everything by 2/3. All right. Which makes this all nice and messy. 11 or 33 over 2. Subtract it. -27 over 2 squared gives me 729 over 4. Okay. Find a common denominator. All that good stuff. There you go. Check your work. Have some fun. Adios.